Hello everyone. So today I'm gonna talk about my 15400 research proposal, which is graduate verification on CNOT. So here's the research team. It consists of Professor Jonathan Aldridge, who is also instructor for this course, and Jenna Weiss, who is a PhD student at the Institute of Software Research. So to actually talk about the concept of graduate verification, we first need to talk about static and dynamic verification. So basically, static verification is to verify the correctness of a piece of code without actually running the code. Currently, most static verification is based on Hoare logic, and Hoare logic is based on contracts like requires and ensures. And pretty much everyone has seen that in 122. So let's go through this example. Initially, we have balance 100, and in the first withdrawal, we can probably see that it only ensures balance is greater than the amount, which is true. And then after we withdraw that amount of balance, the only thing that it ensures is that the balance is non-negative. So you can see that in the second withdrawal, if we do the verification solely based on the contract, we can not guarantee the balance is non-negative. Even though during the runtime, we definitely know that the balance is non-negative. So that's a limitation of static verification. So dynamic verification, we are all very familiar with it because in 122, the contracts are all dynamically verified. So dynamic verification means that all the contracts you wrote will be compiled with the source code, and during runtime, all the checks will be performed. So in this example, you can pretty much see it will not fail any contracts and will not produce any warning. So we already seen that static verification and dynamic verification each has its drawback and advantage. So here comes the concept of graduate verification. So here's a citation from paper written by Professor Jonathan Aldridge. So graduate verification supports both static and dynamic checking and the entire spectrum in between, driven by the precision of programmers' annotations. So you can probably see that graduate verification is something in between of static and dynamic verification. So while some of the contracts we can definitely verify them statically, some of them we don't have enough information for that. So graduate verification is basically so it deals with missing contracts in static verification because static verification will require the user to fully specify everything in all the functions. So in the case of graduate verification, if we are missing some contracts, we can perform the verification dynamically at runtime and decide like when we should go into dynamic verification. And also, we can introduce additional information from the code compared to static verification because static verification, as we said before, is solely based on the contracts. So graduate verification in CNOT is gonna be my research topic, and basically my goal is to design and implement a graduate verification tool for CNOT. So CNOT, everybody's super familiar with it, and here's just a screenshot of my 122 homework. So all the functions has a lot of requires and has pretty much one or two, like a few ensures. So the goal for graduate verification is to verify some of the contracts statically before I actually run the code. So eventually we don't have to verify all of them during runtime. So I haven't decided which research question to work on, but I do have a few potential research topics. So the first one would be to extend a procedural language for graduate verification. So we all probably Professor Jonathan Aldridge already wrote a paper about graduate verification. And the paper is pretty much more about the general framework of how to do graduate verification. And in here, by working on CNOT, we can design a more specific framework on how like graduate verification works with procedural language like CNOT or Java. So and another topic, performance-wise, is to eliminate some CNOT dynamic runtime checks and perform them statically. So this is a performance challenge. And the last one is the use of verification tool in teaching context. which can be also like a very interesting topic to work on. So here's the references, and thanks for listening.